Hello, this is Hassan again, and today we will begin with lecture 6 and 7 for your work. And hopefully, we'll cover a lot of topics today, like starting from we will deeply discuss ANOVAN function and what are the different possibilities we have, what kind of different tests we can conduct with ANOVAN functions. Then we have other functions as well, like t-test and t-test2. After that, like we will discuss about plotting, and if there is a time remains, then we will come back to the previous lectures where we have to actually discuss about missing values and how to actually count values by using group by functions in MATLAB. So it's going to be comprehensive lecture, and let's begin with our first topic of the day, that is ANOVAN function in MATLAB. Oh. So let me just give me a heading. So the generic notation for ANOVAN function is such that we equate it to P. P is for like P values that we use to distinguish between tests, and also it is used to either that is set as a criteria for testing the null hypothesis, that whether we will accept it or we will reject it. So the notation is such that we assign a variable p, then we assign a function ANOVAN. Within the braces, we will declare a variable y and group. So this, for right now, it takes multiple inputs. For right now, we will stick with two inputs. The first one is y and the second one is group. So let me explain in a bit more in detail what these values mean, and how we can interpret it, and how we can use our data set, any kind of data set, to feed it through these two variables y and group. So the y here is actually the vector to be analyzed. Okay, so what you are trying to study, what is the impact on which variable you're trying to study the impact of. So this is y. The other variable is like group, and it's a little bit clear by its name that it's like we use it to validate multiple factors. I will discuss that in a moment. What do I mean by that? Grouping variables for a matrix defining multiple factors. So basically it means that we have a y, which is a parameter, this is a variable or some quantity that needs to be analyzed, that needs to be studied by what are the effects on this y vector, and we can study it through a group of factors, or it could be one factor, it could be multiple factors that has an effect on y. So in other definition, we can say y is actually dependent variable which depends on multiple factors. So these multiple factors are independent variables. So that's a quite brief definition of ANOVAN function, and what are the inputs. We have two inputs, y and group. After that, let me give you something like that. So basically, ANOVAN function computes a multi-way ANOVA for testing the effect of multiple factors, where we define grouping variables on the mean of response variable y. It returns a vector of p values with one p value per term. That is, it will return a vector, a set of p values, where each p value will correspond to one factor. For example, if I have one factor that has like something like age, then other factor is like location. So it will return two p values. The first one will be related to age. The second one will be related to location, which will in turn signify the importance of each factor's effect on our y that needs to be analyzed. So other than that, it also displays standard ANOVA table. So you will discuss that. I mean, you will see that in a moment. So let's move on and create a space for right now, and then again define a text. And for today's lecture, we are going to use a data set from a marketing perspective. Basically, it is a customer's data that has been gathered, and they have actually gathered data how the customers are acquired through different marketing channels. They have different demographics like age and their gender, their date of birth. So we are going to use this data. You're going to use this data set for our analysis and in order to understand ANOVAN functions. So, so basically, it's a marketing characteristics data sets. And within that data set, we have variables like marketing channel type, then we have gender type, and another and some other particular of our interest is location of the customer. So we want to study, let's say we want to study these impact of these factors on total profit that the company made throughout this through these customers. So let's load our data set. For this, I will define another code block. Let's define an Excel file name. In our case, I'm going to use df put underscores quotation marks, then df customers dot xlsx. Okay, then I'm going to load the data and I'm going to rename it as marketing data. And this will be, and the function we are going to use, as we have discussed in the previous lecture, is going to be read table, and simply we will assign our value here, that is Excel file. And after that, I'm interested in only visualizing a few rows of the data frame. So I'm going to use head function and pass the input argument marketing data. Let me just run this block right here so we can actually visualize what the data is all about. Okay, so it says that it's not able to actually find this. I think I have just misspelled customers, so it will be basically just customers. So let me run it again. So we are good right now. So let me discuss and tell you about, okay, we have a gender. I told you like we have gender like male and female. Then we have there is another category which is not defined, that some customers don't want to define or specify their gender. Then we have marketing channel type, what kind of marketing channel was used to acquire these customers. Then we have finally our total profit, like what is the total profit made by each customer. And we had some other more columns like age. We have like what kind of what was the total expenditure was spent on these customers in order to acquire them, but then what is the first order profit and things like that. And whether these customers opt to like whether these customers allowed them or the company to be contacted by email or telephone. So these are some generic and some robust data so we can actually test an ANOVA function. So before we actually start running ANOVA test, we first have to declare some variables. And if you look at the generic notation, I told you that we need to define two input variables: y, that is the vector that needs to be analyzed, and group variable, the factors that will affect y. Okay, so if based on this data, the most generic and most reasonable approach to use y, you can think of it like the most important factor or the most important element the company might be interested in will be the total profit, like what customers are driving the most profit, whether what kind of gender is it driving the most profit, and what is their age group that is driving the most profit, or what channel is actually driving the most profit. So in our case, from a data analysis perspective, we are interested that we want to know study the impact of total profit by multiple factors. So in y in our case will be total profits. But remember that this is a Tableau data format. As I have told you, like we will use the same notation: marketing data dot, we'll assign the column name total profit. Okay, that's it. This is our response variable. Then we have to define the group. Basically, group is just what are the factors we want to study that will impact this response variable y. So for right now, I'm interested in three variables or three factors, and I'm going to use as these factors will be gender, female, male, female, or not defined. Then the factor will be the location, and other than that will be marketing channel type. Here it is. Okay, so these are the three factors I'm going to study the impact on total profit. So in order to declare that and so that it is usable for this ANOVA function, we have to actually create a cell list here. Okay, so for cell we are going to define curly braces, and the notation for getting stacking table data from marketing data is the same. We will first assign marketing data, write marketing data, then we'll use dot notation and define the column we are actually using it. So the first one is gender, the second one is location, but yes, location, we're going to use location. So, and the third one will be marketing channel type. Okay, and keep that in mind. All these three columns, gender, location, and marketing channel type, are of character values. Okay, they are not numeric values. So I need to make a little correction. I made a mistake in the previous lecture when we briefly discussed about ANOVAN function. I told you that we need to pass numeric values, but that's not true in MATLAB. You can actually pass character values, column that contains character values, and you can get that result easily. So that's why we don't need to actually convert that data into numeric values for ANOVAN function. So we have declared our y, we are declared our group factors. Then it means that we are good to go to perform our ANOVAN analysis. Okay, so this will be a three-way analysis. So let's perform this analysis. So P is equal to ANOVAN y comma group. So y will be the independent variable. So dependent variable group are the independent variable that will contribute to the value of total profit. So let's just run it. Okay, there might be a typo error. So as you know, we have conducted our test. Let's just briefly go through this table analysis of variance and ANOVA analysis. The x1 will correspond to the first factor we input to this function. X2 will be the second, and x3 will be the third. So in our case, the x1 will be gender, x2 will be location, and x3 will be marketing channel type. And let's look at p-values. And by looking at p-values, we can you can also see p-values here, and you can also analyze p-values here. So looking at p-values, we can see that the effect of gender and the effect of marketing channel type is actually statistically significant. I mean, this p-value demonstrate a strong evidence to reject null hypothesis and accept alternate hypothesis that gender and marketing channel type do affect the output of total profit. So this is a very quite generic, I mean, this is a easy way. The first thing you will define y, which is the predicting variable, the independent variable which will be affected by the group factors. And group factors, you can define multiple group factors. For right now, we have only defined 3-1, and that's why it's called three-way ANOVA analysis. So that's how it is. But we are not done with that yet, and we have multiple options that we can actually perform with this function ANOVAN, and we are going to discuss that. So based on that, we have, like I already told you, that we have like y and group and ANOVA results, and you know that lower the ANOVA function returns a vector of p-values. And also one more important thing, that this returns a vector of p-values where each value of p corresponds to the individual group factor. So p1, this one, like 0, 0, 0 will correspond to gender, and p2 will correspond to location, and p3 will correspond to marketing channel. So this is a quite simple approach to actually do an ANOVA analysis. So but this function has multiple inputs that we can pass it to actually get the exactly the same analysis we are looking for. So let's discuss its features and options that we pass as an input argument. So let me just rename it name value pairs, that is okay. So we have that thing, and I will just rename it, make it a heading. Okay, let's move on. So how we actually define name value pairs? It's quite easy. We have already discussed the ANOVAN function notation, how we actually define this function. So we have our y, we have our group, then we will define our value. So, and this value can have multiple values. Okay, so name value pair additional, these are the additional options that you can specify, such as specifying the type of sum squares or to use, or whether a variable is continuous or not. Okay, I will write down the list here for you. So variations of value options in ANOVAN. Okay, the first one is actually continuous, and I will teach you later with a simple example what does it means by. So basically continuous indicates which predictors are continuous variable. Variables. To save time, just not really focused on about the spellings, so we can, like, you can actually understand it. The second one is like var names. Okay, it specifies the name for the factors in the group. Then we have the first one is continuous, the other one is var name. Then we have model specification. we will define model, and there are three models, I guess. Model to fit. Then we have display, and I believe this displays additional options through ANOVAN. And finally we have SS type. Basically it specifies the sum of square error to use. What kind of sum of square errors you want to use it. Let's start with the continuous one. What does it actually means and why do we actually use it? So basically if you look at the data frame here, okay, we know that gender is a categorical data, the location is categorical data, and the marketing channel type is also categorical data. But we have other types of data that is not categorical, that is not discrete, but is actually continuous. And age is such an example of that data, where age is a continuous variable. The factor is a continuous factor that we need to study the impact of its age on total profit. So in this case we have to actually specify the function that this age is actually a continuous function and it's not a categorical function. So let me define the code. First of all, let's define our y, which is again will be total profit. So it will be a total profit. Then let's define a group variable, the factors that will create an impact on total profit. So remember, we will define it in cell format. The first one will be, again I am going to use gender, and I'm going to leave a location, and I'm going to use age, which is again, remember that it's a continuous variable. Data dot. Finally, I'm going to assign marketing channels. So we have our y and we have our group factors value. Now let's perform ANOVAN, and we have to actually declare that this age is actually a continuous variable. So how we are going to do that? Let me show you. E is equal to ANOVAN y comma group, and then we define the value, name value pairs. For this purpose I will use continuous. So I'm going to just select that option, and after that I have to actually define or index the column that has actually continuous value. In our case it's indexed at 2 because one is for gender, 2 is for age, and the third one is for channel type. So we have to actually define the index here. So in this case our index will be 2. So let's run this analysis and see what kind of p-values do we get. So you actually see that all three of these factors, gender, age, and marketing channel type, significantly contribute and alters the total profit because the p-value of p is quite less than 0.05, and I mean it is almost equal to 0. It means it gives us strong evidence that we can reject null hypothesis and accept alternate hypothesis. So we have actually studied what is the impact, why do we actually use this continuous name value pair. Let's move on to the second one, which is actually var names. Okay, so what is the significance of var name value pair? So we are going to discuss here right now. Let me just change it to text value. So var name actually gives you just it actually just renames your or factors here. If you recall, if you look at this table here, we have x1, x2 and x3. The x1 correspond to gender, x2 to age and marketing channel type for x3. But instead of that quite vague notation, we can actually replace these x1, x2, x3 by some reasonable notation that anyone can able to understand the analysis of variance table. So let's do it. So basically we don't need to actually define anything new. We have already defined our y and group and the continuous function. All we need to do is then another name value pair, that is var name. So let me just do it for you right now. P is equal to ANOVAN and curly braces, then I define y, which is the predicting variable, then I define the group of vectors that creates an impact on y. Then I have to define, like, okay, I know I have defined three variables, but my some of the variables that I have defined are actually continuous. So I have to actually tell this function this thing. So 2, that is age, is actually a continuous function. Then in the same way, we can define multiple var names. For right now, I'm going to define var names. Then I'm going to assign a value or rename those columns. So it can be displayed in ANOVA table. So the first one is actually gender. So again, I will pass it as a cell type data. So the first one is gender. So I'm going to write gender here. The second one is actually age. So here is the age. And the last one is actually marketing channel. So it gives a more descriptive meaning to our ANOVA table. So let me just run it again. So now you can see that this ANOVA table is actually more descriptive. As you can see that it gives a separate meaning for gender, age and marketing channel. And then finally we have a p-values, and this doesn't change, like the p-values are quite good with a strong evidence to reject null hypothesis. So after we have done that, let's discuss another value pair that is model. Okay, and let me just give another heading. Model. This is another important feature for ANOVA, as we can specify multiple model for conduct analysis of variance analysis. Okay, so basically there are three models that we can use to actually conduct our ANOVA by this ANOVA functions. The first one is linear. The second one is actually interactions, and the last one is full. The linear is by default model, even if it means that if you don't put any value or don't assign model and any value, it is by default set to linear model. And it only computes the p-values for all null hypotheses on the n main event. Then we have interactions. The interaction model computes the p-values for null hypothesis on n main effect and n commutation to two-factor interaction. It means that it also computes the interaction between factors the group factors that creates an impact on predicting variable y. So basically it will also consider the impact of gender or age. Well, like what is how the gender or how the age is impacted by gender, and how the marketing channels, like which customer was acquired by which channel, is impacted by either age and gender. So this is a two-factor interaction analysis too. So it does that too. So p-values and also interactions. Finally, we have the full model that computes the p-value for null hypothesis and make events, effects, and interaction of at all levels. So we have three values here. So let's discuss how we can actually define these options in ANOVAN functions. So we are not going to change anything, but let me just copy paste that grouping factor so you are able to recall it again and again in order to just moving out from top to bottom. So I'm just going to comment it. So because we have already defined the options, so let's define it. Right now, we know that we have already conducted linear because I told you that by default the value is set to linear. Let's discuss and do it for interaction model. So for this purpose, I'm going to define three models. So let me do it by P1, P2, and P3. That will make more sense. So P1 is actually the same model here we have defined. And I'm just going to assign a new variable, name value pair. The thing is model. And then I'm going to assign the value. The first one is linear, which is the same as the previous one, as we have already done that. Let's define another one, P2. So it's going to be, let me just copy paste that because we don't need to actually write it again from the beginning. So the second one is interactions. Okay, then the last one is actually full. And then let's visualize those values and results. So it's model full. So that's how you actually define a model. You define the model parameter, a name, then its value parameters like linear, interaction, or full. So let me just run it. So when we run that, the first one is actually similar as we have already run that. But let's look at another model that is used interactions. So okay, I think I have some typos here. Is without S and this. But right now you see that we have actually 6 values. So let me break it down for you. The first 3 values will be the corresponding p-value that will identify the effect of gender to total profit. The second will identify the effect of marketing channel, and the last one will identify the effect of age. But now we have also given we can also see the distribution here. The fourth one, which is actually this here, actually is the interaction term between gender and age, and the fifth one is the interaction term between gender and marketing channel, and the last one is the interaction between age and marketing channel. So this table itself is quite descriptive, and you now understand the first 3 p values are actually contributed there to the effect of groups on that has on y. The other thing is last 3 are the interaction terms. And the same thing is here for this thing, like full. We have marketing channel, then we have gender age, this, and finally we have an interaction of all of these values, that is gender, age, and marketing channel. So as you recall that I already told you that this full model actually computes all the effects interaction. So this is how you actually define and use different models for ANOVAN function. Let's move on to actually the last variable. Now we have actually two name value pairs. The first one is quite simple, and it's display either on and off. By default, it has a off value. So how we can define it? We will use the same notation we have actually defined. So I'm just going to copy paste it because it's nothing new to actually write it again and again. Let me just write linear here. Take that. And I will then define another input variable, display, and then I will set its value to on or true. And in that case, it will be on. So that's why it's like displays an additional information. But what if we actually set it to off? So you see right now, I mean by default its value is on. Let me write to you. By default its value is on. And if you want to turn it off, and you means that you are just only interested in p values, then you can set it to off. Okay, that's it. And the last one is actually SS type, which identifies the sum of square error that we want to use in order to conduct your analysis. So what is SS type? Basically, it's a type of sum of square error specified by either using a comma separated value. And we have three types of sum of square error: the type 1 sum of square error, type 2, and type 3. The type 1 is just the reduction in residual sum of squares obtained by adding that term to the fit. I mean, you can actually study this terminology from the MATLAB website. So other than that, I mean, you can also go to your textbooks for further clarification. So what are type 1, type 2, and type 3 errors? Okay, so let's see how we can actually identify all those values. So for example, if you want to conduct an analysis for a specific using a specific type of error, so how I can actually do that. For this purpose, I'm going to just define our ANOVAN function. P is equal to ANOVAN, and then we have y comma group, and let me just copy that out. So we have this values, and let me just get rid of that display of. So how we can actually specify type 1, type 2, and type 3 error. So basically we just write SS type, and then we identify the model. So in our case we have either 1. So let me just run it through all values. So let's see if there's any change in p value. And in that case, we can also use this display option off because we are only interested in p value and don't want to see all other informations. One, two, and we have 3, and let it be 2, and let it be 3. So let's see. Well, is there any difference between the p value? Obviously, there would be a slight difference, and it could also change based on the complexity of data. But right now we can see that the values are quite same, and because the p value is quite low, so it doesn't have to be that much of a difference because it's quite near to 0. So basically this is how you actually define and use ANOVAN function with multiple set of features. and we have discussed that in detail. Okay, so let's now just conduct a simple P analysis in order to test our hypothesis. Okay, so you recall that we have three growth factors that could put an impact on our y predicting variable, that is total profit. These factors were what? The first one was actually gender, the second one was age, and the last one was actually marketing channel, how the customer was acquired. So let's check P for null hypothesis. So we are going to use conditional statements to create a simple algorithm for either accepting null hypothesis or rejecting null hypothesis. So let's say we know that we have P value. So P, if you just take this function here, we have already conducted the analysis, so we don't need to actually run this statement again. So I'm going to write P1 if P1 is less than 0.05, which is our setting criteria, then we'll display the value or something like that, significant effect of gender on total profit. And if you recall that, let me just put the text here and so you can okay, so we say that if that statement is true, then we can say that significant effect of gender on total profit, which is another way of saying that we have strong evidence to reject null hypothesis. This is so we accept alternate hypothesis. Okay. In the same way, we can create other conditional statements for P values, like if P colon 2, which you recall is actually related to age, which is a continuous variable, we will display significant impact of age on total profit. That is it. And finally, we have P3 value. If P3 is less than 0.05, which is in our case is true, then we can say that there is a significant effect of marketing channel on total profit, and then we finally end it. So let's just run it and see. So we have all the values were actually quite less than 0.05, and they were quite close to 0. So for all those three tests, the null hypothesis was rejected. So this is how we can actually automate a process of accepting or rejecting null hypothesis. So let's just briefly talk about the outputs of this ANOVAN function. What are these outputs are? First of all, p values, which is quite obvious that we know that p values are the actually we are used for using conducting test uh, to see whether null hypothesis could be rejected or accepted. So these basically there are three main output variables for this ANOVAN function. The first one is how we can actually extract the values. So this is the notation, we take it as a list value. So we have p, then we have tvl, then we have stats, and the packet closed through a square bracket, and then whatever the ANOVAN function you actually want to use. So p values, you know that here p values indicate the significance of each factor and their interaction, or it could also signify the interactions of grouping factors with each other. And then we have TBL, which is an ANOVA table. It provides details about statistics, including sum of scales of degree of freedom, mean square, F values, each factor interaction. And let me just run it for you so you can actually see that. So it is this. So let's display p, and the same way we will display other values. So right now you see that this TBL is actually an ANOVA table, and it have all the values like sum of scale values, degree of freedom, then we have least square, mean square errors, F values, and interacting P values. Okay, and then we have this stats, which actually display us give us a number of information about this analysis. And if you want to extract some certain information from this stats, we can actually use structure notation and put stats, then any value you actually want to extract the values of. So let me see, let's say we are interested in coefficient names. So you see that this we have actually extracted our coefficient name. We have like constant, gender male, gender female, gender not defined, then we have age, then we have 5 categories of marketing channel.